Hello and welcome to the first lecture for design programming. I want to just firstly, before we get into the content, apologize that this video is going out a couple of days later than it should. I had intended to get this video out by the end of Monday. It is now lunchtime on Wednesday and class starts tomorrow. That's entirely on me. A couple of things come up this week. I had to step in to do some tutorials for a tutor who was away. I have a couple of health issues in my family. These sorts of things happen, and this is why you shouldn't leave things to the last minute. Do as I say, apparently not as I do. But let's get into it. Before I get started, one second thing that I want to note is that where I'm standing right now on the University of Sydney campus is the traditional and unceded land of the Gadigal people. And for all of those who are elsewhere in Australia, as well as elsewhere in the world, I'd like to just take a moment to consider the traditional Indigenous owners of the land on which you're sitting and the ways that we can continue to embed their knowledge, their practice into our values and our systems as we go forwards. Hotkeys. Programming. Programming is the language of our modern world. This is a couple of lines of code written in P5.js that uses 3D libraries that are written by other people that use the infrastructure of P5, of JavaScript, of the modern web. At once, this was something that someone like me is able to put together fairly quickly. But at the same time, this is the collective work of 1,000 people coming together to produce a goofy little shape thing on my computer. It can be run just in my slides that are running in Chrome on the machine down there with no particular hazard, even though it's doing something that even 30 or 40 years ago would have been at the forefront of multimedia art. It's now just a thing in your browser. The difference is the way that we are able to, on a very high level, simple set of instructions, control the machines that surround us. But you might ask a question. Why do I, as a designer, need to code? Why do you, as someone who sees your role in helping shape the experiences that we have with all this technology around us, why do you need to learn to program them? After all, race car drivers don't necessarily do their own engine maintenance. The answer is, well, let me tell you a history story first. About 25 years ago, and in the late 90s, a fellow by the name of Alan Cooper released this book, The Inmates Are Running the Asylum. And it was really a complaint about the way Silicon Valley, the tech industry, this is pre-dot-com bubble, mind you, the way the tech industry was structuring things. The inmates, in this case, the engineers, were running the asylum. Products were being created where on the outside, on the interface, they looked exactly the same as they look on the inside. His big impassioned plea was that we need designers. We need people who understand what users want. We need people who understand what users know. We need people who understand where users are when they use our products so that we can present the services and the products that we're designing to them in a way that makes sense to them, not in a way that makes sense to the database that backs the whole thing. This was happening on the engineering side of things. As it actually happens, there had been people who'd been pushing this kind of idea that we should study how people use technology. This is the inimitable Genevieve Bell. She's currently a professor at ANU. She was trained as an anthropologist, a cultural anthropologist, and she found herself almost 10 years before Cooper wrote that book in Silicon Valley helping companies understand what it is that people do with their products, helping understand the home environment, the office environment, and trying to persuade people, actually, yeah, you need to take an anthropological view. You need to take a person-centric view when you're doing all of this technology. It is expected that you, as a designer, know how to present products to people in a fashion that they will understand. Something has changed over the last I don't know, 5 to 8 years, maybe 2012, 2014 is when I started hearing about this. I'm usually a couple of years behind cool people, so let's say 2010. What changed was that people started talking about unicorns. We'd gone full circle from having the engineer be in charge of everything to having the designer be in charge of everything but not know how the machine underneath them works. So if you were one of these mythical designers 10 years ago that knew how to code, you were considered a unicorn. You were someone who could not just envision the thing but make the thing. This is the way we marketed the Bachelor of Design Computing for a long time, but things have changed. We're now no longer in a world where there are just a few unicorns. We're now in a situation where, to ape Alan Cooper for a second, I feel that the unicorns are running the asylum. Everybody is expected to be a unicorn now. Every designer of interactive products and services, every designer of products that have a digital component is expected in some sense to know about the machine underneath the stuff that they're designing. This is actually a P5 sketch. I can click on it and add new unicorns. You can check out the lecture slides if you want to do that. If you want to make emoji flavored trash in this course, we will absolutely support and enable you in your quest to do that. But things have changed. There was a survey about 5-6 years ago now that showed that 93% of designers thought that coding knowledge was essential. It turns out unicorns are running the place. So that's why I think it's important for you as a designer to know how to code, because it is now. It is just the language that we use as designers of digital products and services. You will benefit immensely from being a designer who codes. By using code as a prototyping tool, by being able to read the code of others, by being able to have a conversation with an engineer who says, no, we can't do it that way, it's so hard. That'll make it take 3 months to get the database working the way you thought would just be another way of presenting the screen. We can have a conversation with them and say, all right, what's the structure of the data underneath? Why does this one so much harder? Why is this layout that to me looks pretty similar to this layout, why is this one so much harder to do? I'd be able to be a better designer if I understood the structure of the database underneath. So you will not only be able to work with engineers, but you should be able to take a design from nothing all the way through to a finished product. From another angle, another way that I think people can draw value out of this course, code is a medium for artistic expression. Creative code, as a phrase, means the use of programming to make things. Liam and I are interested in particular about a certain kind of creating coding, which is generative design. Generative design, you might often hear it called creative AI or something like that, is art that in part makes itself. Here's a little example for you. It's pretty straightforward, but every time I click on this, it generates a new diagram, obviously in the same style. It's just moving around those lines, but these are different generated artworks. These processes, the algorithms underneath this sketch, help in the creation of an image in this style. They can produce things in infinite variations just with this really simple collection of 10 lines or something or other. I think it's worth thinking about this idea of generative design as an angle for programming, because this is actually something that has characterized computing and AI from well before their inception. Some of you might be familiar with Lady Ada Lovelace. She worked with Charles Babbage when he was putting together the designs for his analytical engine, later called the difference engine, which was an analog computer. It could do, it could solve functions, solve equations. It was never built to the specification that he wanted. It never actually worked in his lifetime because manufacturing processes were just simply not accurate enough to be able to get the gears that all worked together for him. But Lady Lovelace, Ada, Countess of Lovelace, worked with Babbage and imagined the things that this computer could do. She didn't use that term, of course, that term came much later, but imagined the things that it could do. She wrote on in her memoirs, actually in the notes of a translation of some French text or something. Like always, these people from hundreds of years ago always had these fantastically huge collections of skills. The analytical engine has no pretensions to originate anything. It can do whatever we know how to order it to perform. Those emphasis is hers. She wrote that in 1842, and it kind of characterizes how we think about artificial intelligence now, right? Like, AI can't really originate anything. AI can't really surprise us. Now, it's that surprise angle that was focused on by one of the fathers of modern AI, Alan Turing. In a famous paper that he wrote in 1950, he said, actually, machines take me by surprise with great frequency. His interpretation of what Lovelace was saying was that a computer could not originate anything, but that doesn't mean that we, a human, could see every possibility. That you could program something that was complex enough that you wouldn't be able to see exactly what it would produce, and so then when it produced something that wasn't what you expected, you would be surprised. And that is the space in which creative AI and creative code and the kinds of ideas about code as an art platform sit today. Coming forward from the 1950s, it's actually, people have been using code to make art for a really long time. This is Harold Cohen's Aaron, which is a painting robot. I think this image is from 1988. It's meeting on Gauguin's beach, inspired by the famous artist Gauguin. And Cohen taught Aaron to paint, in a sense. And Aaron is a robot. Aaron was actually a collection of many robots over the decades, but here's one of them. Initially, they just drew outlines, and then Cohen filled in the colors himself. But over time, Aaron became able to apply pigment as well. The system became more sophisticated, more able to draw in specific ways, and over time, Cohen described Aaron as the artist. That's a bit of a provocation as well, as in, is Cohen writing the code, right? Is the art Cohen's? Is the art Aaron's? Can an artist without consciousness be said to be an artist? These are questions that are worth exploring now at the dawn of AI-mediated everything. Because even though I would argue that Aaron wasn't making art, Cohen was making art with a complicated generative process that he happened to call Aaron, that's not necessarily always going to be true. And it's worthwhile thinking about where the line is. So Aaron could tell the difference between foreground, background, knew different kinds of figures, humans, plants, other objects, and could make sort of composition choices. Aaron thought about where to put things. It didn't just draw randomly. It thought about where to put things based on principles of visual design that Cohen had built into the system. These were mostly popular in the early 90s, and they were so far ahead of their time as far as robotic art goes. Now we have sort of machine learning generated paintings selling at auction at Christie's. But in the 90s, this was pretty out there stuff. So we're going to be taking some inspiration from some of these examples of computer-based art and generative art and creative AI throughout this course as we start to think about how we're developing our own skills of creativity as creativity through the means of programming. We're going to be thinking about how other people have tackled those same problems over the years and what we can learn from the philosophies and the achievements of these earlier systems. This is actually one of my favorites. This is one of Aaron's earliest works, one of the ones that had only outlined. You can see sort of like a Red Riding Hood style figure in the top right hand corner here. This is one of its early attempts at a human figurative representation. You can see some of the others are edging in that direction. I've got to be honest, I like these early works a lot more than some of the later ones, which had a more direct figurative representation. I think the more specificity Cohen gave it, do figures like this, use the colors from Gauguin's palette and some of his work on depictions of Pacific islands. The more specific it got, the less sort of interesting, the less space for interpretation there was. But that's just my opinion. There's a lot of different aesthetic choices going into this. Let's talk a little bit about some more modern examples. I'm done with my history lesson. Algorithmic design can now be found everywhere. Here's a couple of examples. Here's one from my own work. This is some stuff I did in the US about 5 or 6 years ago with a bunch of very capable collaborators. The top line is a bunch of drawings, little sketches that you would put together of bridges. The system would say, hey, draw me a bridge, and you would go and you would draw bridges of these many different kinds. And the system, we called it the sketching apprentice, would take what you drew and say, hey, that bridge looks a little bit like, and then pick a similar drawing from a very different object. It knew how similar a bridge was to a rainbow. It knew that a rainbow is a very different thing to a bridge. So it says, yeah, that bridge, that looks a little bit like a rainbow. Here's a rainbow that's like that. Or that bridge looks like a beach. Or that bridge, this one I love, looks like a shark, or a church, or a roller coaster. The idea was to build something that, in Turing's words, would surprise you, explicitly to build something that would help break you out of a creative rut, or help just send you off in a crazy direction. We never ended up building this into any kind of product, so unfortunately you can't go online to check it out. But if you do want to know more details, you can click the link. These slides are online on the CCC's platform, and you can read the papers and see some more examples of the images we put together. Here's an example from NVIDIA, the graphics card manufacturer. They do their own AI research. You sketch what's on the left, and it renders it as if it were a real image. You indicate, I want this to be grass, I want this to be trees, I want this to be sky, I want this to be water, just by picking from a paint palette. You pick the size of your brush, you draw, and it will instantly render using a kind of machine learning algorithm called a generative adversarial network, a GAN. It will instantly render a real-ish looking image using, from nothing, from pixels, using the data that you give it as stimulus. I find this fascinating. You can actually play with it yourself, use it in your browser from that link there. We won't get to cover too much machine learning in this course, but what you learn in this course as creative coding can be used as a foundation for going more into designing with AI, which is actually Liam and my area of expertise later on. So I'm obviously trying to saturate you with cool things from that space first and foremost. Here's another example of some of the amazing stuff people are doing using code as an artistic medium. I hope this video plays. Might pop it onto full screen. I said might pop it into full screen. Interesting. This is an artistic projection filled with sensors. It's in Odaiba in Tokyo. Apologies to any Japanese speakers, I almost certainly mutilated that. And this is by an artistic collective called Team Lab. The projections are seamlessly put onto all surfaces of this room. The artworks move around between different rooms. They interact with you. They interact with each other. You can leave your mark on them as it influenced them in the long term. This is obviously from pre-COVID, and ironically they were promoting the idea of a borderless world. And then right after they finished this, we got ourselves a whole lot more borders in the world we live in. But this shows you the kind of thing that has a physicality, there you go, one world without borders, that has a physicality to it, has an innate connection to the space that it's built in, and yet is also a representation of code and data that goes beyond that space and connects to so many other things. I think it's a fantastic example of coding with art in mind. Here's a great art project that involves AI. So this is Art Breeder. You can actually get to this interface from that link at the bottom there. You can take a character face that was designed by a neural network, another GAN, and you can adjust it by sliders to add different kind of textures or ideas to it. But if you look at the beginning of this video, you can also kind of create its children, mutate its genome, mutate its genes in such a way that allows you to generate offspring related by different images, those that either are just a mutation of a single image or a crossbreed between two images. That is, and then you can go and directly edit those genes. And he smoothly interpolates on all these sliders. Just the capacity to do this is a fantastic expression of where AI is up to these days. And this website, Artbreeder, is doing something quite simple on top of a very, very complicated machine learning algorithm. Here's another artist, Ryoji Ikeda. Again, apologies to Japanese speakers. This is called Micro Macro. I think this is quite a long video. I might just show one or two snippets of it. This is another projection mapped space. In this case, it's actually incorporating data sources, real-time data from a bunch of other things, and showing you, I can't remember, this might be genetic data. You can see more about this artwork at the link at the bottom, and showing you aesthetically pleasing projections mapped from an underlying data set and influenced by the people moving around in the space. That one appears to be solar flares. That one I recognize. It's a really fantastic piece of work, and again, it's an example of the kind of things. Whoa, I hope I don't need to put a seizure warning on this. An example of the kind of things that you can do mixing art and code. So, what are we actually going to be doing in this course over the next 13 weeks? We're going to be learning the JavaScript library p5.js, which is an evolution of the processing language, which was designed to allow artists to quickly and easily learn to draw on the screen. It's our starting point for programming, but it's also a window into probably the most used programming language for all front-end stuff. Like JavaScript powers the entire internet at this point, and in learning P5, you're learning JavaScript as well. Things you'll need. So the CCC's platform does work better in Chrome than other browsers. You can use other browsers, but it was designed for Chrome. And then the P5 reference, the online P5 editor for when you want to go outside of a specific challenge on our platform, and Slack. Those are the basic places you will want to go, in addition to the design programming tutorials site that you can find on the front page of Canvas. Just a little note about Slack. Our preferred point of contact for this course is Slack rather than using email. If you have any questions to ask one of us, one of the tutors, just hit us up on Slack. It's much faster than contacting us on Canvas or email. One of the things that I hope your tutor will be doing in the first couple of sessions is letting you know when and where they'll be available on Slack. They may not be available 24/7. We do not pay them to be 24/7 support for your coding troubles, but they will let you know when they're going to be available on Slack, when they'll be around to answer questions. And of course, your peers and the other tutors will be answering questions that you ask in the general channel and so forth. I really hope to see the Slack thrumming with activity. It's done really great in the past as kind of a hive of help. It was super useful during the worst of COVID when everybody was learning remotely, and I hope it can continue having that kind of vibe as we go forwards. One last thing that I want to add is that the P5 reference website is just a super useful place for you to get familiar with. We're going to be learning in the tutorials how to read and use the reference. You should always just check the reference first if something's busted, and then from there you can get examples of how to use a particular function in your code, a description of what it does. You can get exact syntax. These are all things that I hope you'll become more familiar with over the course of the course. So that's design programming and our creative coding challenges approach to teaching you P5.js. So get into your tutorial, watch the video on how to do this week's first set of challenges with your tutor, and then you'll be able to tackle some of them alone in small groups and do your first example of learning to code. We'll see you in class.